Hello, this is Answer Everywhere. We're taking a look at Ray, which is a distributed framework thingy for calling functions and whatnot. And it's been in a bunch of people have been talking about it. I got sent a link to Ray from someone who's more on the businessy side. So she keeps track of all of the what all the corporations and whatnot are up to. And so when she notices a software library, I think it's kind of interesting to take a look. I think that, so from what I know of Ray, which is not a lot currently, we've looked at a few projects that are in the same general space. We've looked at Kubeflow, which is for distributing machine learning / AI computations. We've looked at Apache Spark, which I think compared to Ray, Spark is more about distributing like bulk operations, batch jobs that are doing a lot of data work. And Ray is more like more focused on low latency, less focused on throughput. And why would you need something like that? I think probably one use case is something like inference. So if you're doing LLM inference, you may have a few GPU clusters and you want to like fan out requests to different clusters and get the results and combine them. So before we look into it, I think it's good to have a general sense of like what we're expecting to see, what to look for. And so you can do something like create a gRPC service with a single method run script that executes that shells out to, let's say, to a Python interpreter. So run script that takes a string when a message is received. The server and returns the result to the client. And so it's going to generate this. And if you want to improve this slightly, you can have a sense that like some services are more GPU friendly. You write up some YAML and have Kubernetes or whatever run the GPU service on the GPU machines. And similarly for the CPU compute services. And if you want to have something like an actor, where you can send it multiple commands, then you can have a streaming version of this run script command where you can stream. So you just have some RPC thing. It's got a string code, a string result, and then this is the servicer. And it's just going to take the request, call on a subprocess, run the thing, and return the result, right? So this is like something you could do in a few minutes. When we looked at, I think it was Kubeflow, a lot of the work in Kubeflow was taking something like Python, I think it was literally Python, and giving it essentially like stronger types, giving it more structure so that when you spread out the computations, the engine that scheduled the compute and all of that had more structure to work with. But you can imagine something just as simple as just literally sending the Python script over, or you could even imagine just SSHing into a box to execute remotely. So I don't know where along that spectrum of just spending 5 minutes creating this on the one hand versus the like I think it was Kubeflow style of basically like re-engineering Python so that it was better, where this lands, but I imagine it's somewhere in between. And then once that basic framework is up, I suspect that a lot of the value of something like Ray is going to be in the individual libraries. So now you want to say, people want to use PyTorch. Well, it's not always obvious how to break up the PyTorch commands. So there will be libraries that are like, people have thought about this and this seems like a reasonable way to do it. So that's the sort of stuff I expect to see. We're just going to focus on core, unless it only takes like 4 minutes, in which case we'll look at some of the other stuff. All right, so I see they have Bazel here. I'm not sure. So they're using the Bazel build system, presumably. I don't know what binder is. CI is going to be continuous integration, which reminds me that one difference between this and something like a continuous integration service, like we've looked at Arco CD and a few others, is that in continuous integration, your jobs are long and slow enough that you can just have the cluster management system handle dispatching jobs to different machines. They're essentially cron jobs. So you can just treat them as cron jobs, throw them in a container, etc. But for something more real-timey, you want to do it at the application level rather than at the level of the cluster management service. Okay, so we have a bunch of languages: C++, Java, Python, Source, and Bazel. Just seems like build stuff. Presumably the individual directories have their own build.bazel. Okay, sounds good. So I don't know where to start. Maybe we should start at source and then look at C++, Java, and Python. I'm going to guess Java and Python are bindings for Java and Python. If you have C++ at your disposal, I think typically you're going to use that as the implementation language for the harder stuff. In source, we have Mach, Ray, Shims, and Windows. Let's look at Ray. And we see some RPC stuff, so maybe they are using RPC under the hood. A Raylet, if this is following the naming convention of something like Borg and Borglet, Kubernetes and Kubelet, a Raylet will be some process that runs on the worker machines and is waiting for commands to execute. So essentially, the server in the RPC example we looked at from ChatGPT. Stats is probably just statistics util. I think we could safely ignore. So Raylet might be important. Protobuf is presumably going to define the interface. I don't know what the object manager is. Internal could be where some of the good stuff is. GCS, I'm not sure. Design docs is great to have. Core worker in common. So let's look at core worker first, should we? Shall we? Let's look at the core worker.h. This is the header file. And we see the set of gRPC handlers. So it does seem like they're using gRPC and their associated level of concurrency. If you want to add a new call to the worker gRPC server, do the following. And it's got some stuff. Okay, so this does seem to be gRPC heavy. Let's see if we can find the important protobufs. We have common, event, and then GCS service. Is that the Google object store? Let's see if we can find out what GCS is in the context of Ray. The global control service is a server that manages cluster level metadata. Okay, so it's got some cluster level metadata. Presumably, if it's cluster level, it has to have some sort of the ability to have something like etcd or Apache Zookeeper type thing, where there's some kind of global lock service that allows it to keep some metadata that's synchronized using Raft or Paxos or something along those lines. Okay, so this is the GCS service. I think that we're not going to look at that quite yet. Common has things like language. You can do Java, Python, CPP. And we have the worker type, which is a worker, a driver. I don't know what a driver is. A worker is presumably something that just does compute and not like coordination. Maybe drivers participate somehow in coordination. Then we have spill worker and restore worker, which are considered IO worker types. I don't know what an IO worker type is. These might be things to help presumably manage like large data sets. I don't know if these data sets are so large that they don't fit on a single machine or what, but we'll perhaps see a little bit of that. And then we have a bunch of tasks: a normal task, an actor creation task, an actor task, and a driver task. I'm going to guess that actor creation task is like establishing something like a bidirectional channel, and then an actor task is like a task that you send along the bidirectional channel. And then we have some label stuff. I don't know what they are using labels for, but they're labels. Some stuff about node affinity scheduling. This will be affinity in the sense of if you've been talking to like machine 3, should you keep talking to machine 3, or should you do something like round robin, and so on and so forth. Some more scheduling stuff like placement groups. A Java function descriptor. So a Java function descriptor has a class name, a function name, and a signature. And so they're just sending those over as strings. And we have a function descriptor, which is just some union. It's a one of Java, Python, and C++. So these are different, I'm assuming that C++ has roughly the same structure as the Java function descriptor. For example, we have a function name, a caller, and a class name. I'm not sure what the caller is in this case. And then Python is pretty similar. It has module, class, function name, and we're also sending the function hash. And then a bunch of errors. Object in Plasma. I'm not sure what Plasma is, but it's a thing that your object can be put into Plasma. And then you have some out-of-memory error stuff. Node death. Okay, so nodes can die. Actor death cause, so the actors can die, and so on and so forth. A task spec, this is probably pretty fundamental. So this is going to be some specification for the type. It gives you the type of task. What is the name? What language are we running in? What's the function descriptor? So I guess a task is at the function level. You get a job ID, which is bytes. Why bytes? I'm not sure. A task ID, parent. So who is your parent? So that I guess we can do some kind of walk up the graph, parent counter, et cetera, et cetera. Okay. And then, so far to me, this looks like mainly it's about managing the states of the job. And then the individual functions themselves, we're just kind of like sending them as strings. But I guess we may see on the other side how the dispatch works. We have some events, and let's see, the source type and severity. So this seems to be like logging stuff. And is it really just for logging? So the source is like common core worker. I'm guessing this is mainly for error handling. And then here's the control system, the general control service, I think it's called. And let's see if there's anything else. So pub/sub is presumably for sending events. Rake client, I don't think we looked at yet. Serve.proto might be good. And there's autoscaler, which is going to do some sort of auto scaling. So let's look at serve. It's got some auto scaling config, some logging config, a deployment config, and the deployment config consists of things like number of replicas, the number of max requests, queued requests, and so on. Health check timeout. A lot of this stuff is familiar if you've used something like Kubernetes, although I think that where Kubernetes is like a layer below the application level, you might say. This seems to be more at the application level. I think that these are, well, I'm not sure. And then we have request metadata, like request ID, endpoint, call method. I'm not sure how that's going to be populated, but we also have deployment language. I'm not sure if this is the language that the actors are deployed in. I don't know where C++ goes. Seems to be left out. We have a route, which is a string, and a multiplex model ID, etc. And some request wrapper, which is just a body that consists of bytes, and updated object which has some object snapshot, which is bytes. I guess this is some like byte stream representation of the object itself, and we give an identifier to the snapshots. And we have some stuff for polling. We could do long polling. I think long polling is essentially where the client opens sends a request to the server. The server keeps it open until the server has data. And then once it has data, it immediately sends it back. We have endpoint info, endpoint set, actor name list, which is some list of actor names. And then stuff about the deployment versioning, the deployment status, application status. This is all kind of like metadata so far. Fruit costs. Fruit amounts. I don't know what these fruits are. Okay, so the serve doesn't seem to have anything really. It's so far not really telling us about how the system works, which is, I guess, somewhat reasonable because these are protos and you might change the way that the system works, but there should be encoded in this API more something about how the system is supposed to be used and operates. So the client protos has an arg with some locality information, like whether it's interned or whether, I guess, it's a reference. The type of argument this is, whether a data blob or a reference. And that's the local stuff. And we might have a reference ID, the data blob, if it is something that the proto is wrapping, or other. Okay, so I guess reference ID is like, this is some identifier, you hand it to some other service to get the data, and this is like, we've actually wrapped the data. And then type is how to decode the blob, and the type is just a 0. So they're presumably going to use that for something later. We have task options, a message representing valid options to modify a task execution. And these seem to be pickled. I don't know if this is pickled in the sense of Python. In the longer term, if everything were a client, this message would be the actual standard for which options are allowed in the API. Today, however, it's a bit flexible and defined in the Python code. Okay, pickling is, I think, generally a security nightmare, but we're just going to pickle some stuff, I guess, and send it as task options. And then we have a client task, and then we have the remote execution type, which is a function, an actor. A function, I think, in the gRPC world would be like a unary operation. You send the arguments, and you get a result back. Actor is more like a stream. You have a longer living connection. You can send it stuff. It can send you stuff back. Method. I don't know if they mean method in the sense that they're going to consider a method is essentially a function that is called in the context of some class, and then a static method and named actor. And what is this? The task has things like a name, options. Somewhere there are, so we have some keyword args, which we recognize from Python, and we have regular args, et cetera, et cetera. Okay, so this is like the naive RPC service thing I drew up. We've got here, we've got the args, and somewhere we've got a function. We've certainly got what kind of thing that this is. And maybe payload ID is the reference to the payload, or maybe the function was already sent. But I think this is now the mechanism by which we're saying, like, call the foo function on the argument bar, and that sort of thing. And then we'll look quickly at GCS, which is I think is probably going to do coordination stuff. You can add a job, passing in job table data, and you can get the status and whatnot. Here's the RPC service. This is just some information. You can mark a job finished. You can get all the job info, et cetera, et cetera. You can get actor info request, and so on and so forth. And then here's actor info GCS service. So this is going to act, I guess, like a kind of like a service registration thing. And it'd probably look up in some database somewhere. And this is really just this looks to me like mostly like directory services. Although we can drain node. We have this drain node reply here. I don't know. This seems kind of like mixed up the levels, but whatever. And let's see if we can find the services. How does it go? Is it gRPC service? Because we saw a lot of messages, but I don't think we saw a lot of services. Yeah, okay, it's just called a service, but the word service appears elsewhere. So let's just try RPC space. Okay. So it looks like this user-defined service has an RPC method underscore underscore call. Seems to be from Python. And then also method 1, method 2, and these have user-defined messages and streaming. Streaming, I'm going to guess, is what they use for actors. User-defined message 1 and 2, I don't know. So this is used for tests. So we have name, foo, and num, and so on. So I'm guessing this stuff, some of this stuff, like with the fruits and whatnot, are maybe just for testing. I don't know why they are in serve.proto, but that's where they are. Okay, so that's source. That gives us, I think, a good sense of what's going to be going on. Here's Plasma, which we saw that things can go into Plasma. I'm curious now about databases. So let me grab one of these and look up some usual candidates, something like etcd. How about Raft? Okay, so none of that's coming up. How about database? What if we just look in the documentation? By default, the GCS is not tolerant since all the data is stored in memory, and its failure means the entire array cluster fails. What? To make the GCS fault tolerant, HA Redis is Redis. Oh man. Okay, so that's wild. So they're gonna okay. So there's some Redis integration, and we're gonna use Redis in lieu of a real database. Okay, I mean, in lieu of like a persistent database with guarantees. And so maybe their thinking is that if you're using this, if you're using Ray, then you're probably focused on things like getting responses quickly, and you don't have like an LLM inference job that needs to survive reboots or servers failing or anything like that. Okay, so here's Raylet. This should just really be a gRPC service, I think. We've got a lot of flags that are using the kind of Google style. I don't know if we're using literally Abseil. Yes, we're using Abseil for some stuff. Okay. Parse node labels. Let's see what main does. Okay, so there's some init shutdown stuff. If we're in Linux, then we're going to get the environment variable ray ld payload. And if it's not the null pointer and not payload, preload. And then preload is 1, then we're going to unset some other variable. And what are we doing? I'm not reading this. This is kind of dense, long lines. Parse the resource list. This is some sort of startup stuff. And then I assume that at some point we're going to start listening for connections. So for example, we have the highest port that the workers gRPC servers will bind on and so forth. And then we have an agent manager. Let's take a quick look at the agent manager. Some stuff about some node manager. Maybe raylet.h is the place that I want it to be and not main. Let's look at raylet.h. So what? Create a Raylet server. So this is just a description of the method. So you give it, among other things, a client connection to the GCS. You pass in the IP address of this node. I don't know why. I guess maybe main knows what its IP address is and passes it to this class. And some Unix socket to listen on the ASIO IO service tied to the object manager. I forget what ASIO is. I know it stands for async IO, but is it language specific? There's a C++ one. I think it might be C++. And we're also using Boost. So this is setting up some stuff for listening. I don't know yet. It doesn't seem like we're using gRPC yet. Maybe we are in the CC file. And okay, so we also have worker, which is doing a bunch of task stuff, some friend class stuff, and so on and so forth. I want to look in Raylet. I'm not really sure how this works. I guess I can do that and then add gRPC. So I see some stuff in the comments. Hey, no. And then in the worker, we're actually importing gRPC. So I suspect that since we're importing the protobufs, that we're actually doing something about them. Although maybe not. Why include them if we're not going to use them? So we do have an RPC direct actor call arg wait complete reply. Mark detached actor. This is just setting some Boolean to true. Get actor ID returns actor ID maybe of this class. And here, I honestly forget the C++ gRPC interface. But I think that this is possibly doing gRPC stuff here. And we've got this connect method, which has some port. Maybe they're using like the low level stuff and protobufs, but not the gRPC library itself. I don't know. All right. At any rate, this is worker stuff. I think it's basically working the way that we imagined it, although I'm not entirely sure whether they're using regular gRPC. And here's some design doc stuff. Dependencies unready. The actor is unregistered. So this is actor state definitions transition diagram. So that's like 4 lines. And also the ID specification. Okay, so these are like small, like here's a way to do this data structure, or here's how this is laid out in the byte stream. Why do this by hand when there are so many existing formats for quickly taking essentially C structs and turning them into serializing them for the network? I don't know, but this seems to be possibly either that they're doing this by hand or this is the encoding by whatever system they're using. I'm going to guess if they are doing this, they may not just be serializing protobufs. This seems to be something that they're designing and building. All right, so I want to get out of the here. No, I don't. Let's look at this core worker stuff. So now we're on the server side, which I think we were anyway, right? We were looking at the Raylet stuff. So core worker is doing what? The comment here says it's some gRPC handler stuff. And we've got this task counter, track stats for inbound tasks. tasks this worker is executing. Okay, so when you get some tasks, you're going to track some statistics and so on. And metrics and blah, blah, blah. And is it just the task counter? No, I want to go to all symbols. You can become an actor. You can, I guess, say whether something is an actor, whether you are an actor maybe. Let's look at become actor. So to become an actor, you give an actor name, you grab some mutex, and you set your actor name underscore to the actor name that was passed in. And I guess now you are an actor. Here's the core worker class. I think this is what I wanted. And it extends RPC core worker service handler. So this should be a gRPC handler. Let's take a quick look at gRPC C++ examples. Just so I can know what the standard syntax is and if they are doing anything a little bit unusual. So here's a thing that takes a server context and the messages and returns a status. I think this is the standard way of doing things. So whatever they're doing, I think they're doing something a little bit, maybe using the lower level libraries. Let's see what they're importing. Like where does this RPC namespace come from? I don't know. But we can go back to core worker class. Okay, so it's some seems to be a gRPC handler. And what? We've got this, I guess, equality operator. You can connect to Raylet. This is the header still. Public methods used by core worker process. Connect to the Raylet and notify that the core worker is ready. So the Raylet is the, again, just assuming now that the Raylet is the shared process on the physical machines, kind of like a kubelet, that the workers, you can think of the workers as threads in a sense, or processes, and the threads are going to talk to the Raylet to coordinate some stuff. And you can disconnect and you can shut down and all that stuff. And I didn't say it at the beginning, although I had intended to say it, that a lot of this stuff, like coordinating computation across multiple machines, it's not fundamentally different, at least conceptually, from doing async processing or multi-threaded processing. A lot of the same concerns arise. You have to figure out how to chop up your computation into bits that can be parallelized. You have to think about how much, like, storage, for example, each thread can handle. You have to think about whether any data is shared globally. And I think in this case, the Raylet has some global data, which seems to live in memory and possibly lives in Redis. And that seems to be how it goes. But Redis is eventually consistent, right? Does Redis support strong consistency? A single instance of Redis is consistent. There are options for consistency across many instances. Okay. When was this written? Long ago. What if we try Redis strong consistency 2024? Feet of clay, achieving strong consistency over, I don't know. Doesn't seem like I see a lot here. Let's ask Gemini. Does Redis Support strong consistency. No. No, says Gemini. I believe it. Okay. So let's take this. Let's also do the following. I'm tired of GCS common race syncer. Let's get rid of that. Agent manager. I'm not sure what this is. Manages a separate agent process. In constructor, it starts a process with agent commands plus some additional arguments. Raylet outlives agents. I don't know how an agent is different from an actor. I'm guessing the Raylet spawns agents as kind of like additional Raylet helpers, but those are different from the perhaps different from the workers. This means that when Raylet exits, the agents must exit. Okay. So something about something about agents and what? Then here's Raylet.h again. Let's take a look at Ray project gRPC. Well, we can go here. So we have some gRPC server here, and you're going to initialize, and we have some shutdown, and we have this run thing, and we're going to add some channels, add channel arguments rather. And if we are using TLS, then we will get TLS. I hope we're generally using TLS. And then where are the we have this thing, create calls for all the server call factories. I don't know what a call factory is. Maybe I don't know if these are for running the Python and Java code that the users send or what. Create a buffer of 100 calls for each RPC handler. Okay. And so what are we doing? So for each of the call factories, we're going to iterate over the number of threads and say, get this buffer size. I don't know what entry is, but we're going to get max active RPCs. If it's not -1, we're going to set buffer size to this thing. I guess that's resetting buffer size based on whatever entry is. Oh, for the server call factory. And then we are going to create a call essentially for each of these server call factories. Let's see if we can find where server call factories is defined. Maybe in the header. Okay, so yeah, so we are here are the server call factories, and they have a service handler, request, reply, auth type. This is a call queue. So this does seem to be some gRPC stuff. I'm guessing CQ is call queue, but it seems like they're like manipulating the call queue directly. I don't know if that's for efficiency or something else, but it does seem that like perhaps they're a level below where an ordinary gRPC service would be. A gRPC server listens on a specific port it owns. So they're defining their own gRPC server class. I don't know why they're not using the standard gRPC stuff. Let's look in issues. I would hope at least that the first thing they tried was to use the standard gRPC stuff and then decided that it needed to be optimized. Stream to stream. gRPC methods do not work. Can I like sort by oldest? Let's sort by oldest. Ray with SSH port tunneling. So this is from 2017. I don't know what SSH port tunneling is in this context. I'm trying to use SSH port tunneling to connect to Ray on a remote machine. This would be useful for accessing machines behind a firewall in a secure way. Okay. Discuss Ray streaming support, etc., etc. Connect, compile, Ray project suggestions, set up Bazel, direct actor call. I don't know. I don't know how to search for what if I do gRPC upstream? Let's try one more thing, which is we're just going to take this the C++ standard syntax and look for like server context. We have a callback server context. We have a gRPC server context here. And an RPC server call. I think that, I don't know. Okay, so it does seem like they are re-implementing some gRPC stuff. How do I find out about that? Let's take a look at this file and look at its Git history, which I'm sure GitHub has some way of doing, but if I recall, it's not great. Okay, so this is local to the file. Now let's go back all the way back. This is the thing I think you can't generally do in GitHub. Although I can do it on disk, right? Let's grab this file. I can do that, and then how do you do git log beginning or git log reverse? You just pass in reverse. So the earliest is from 2019. It says use gRPC for internode manager communication, refactor RPC server to support multiple I/O services, fix memory leak in RPC, server call, and client call. So let's check out this one. And what does the original one look like? We have gRPC server.h. And we're including gRPC pp, which is maybe the thing that we're not including now. Let's check that. We're including gRPC impl, which is, it should be like an implementation detail. And we're including here, we're including regular gRPC here, but this is only in a util. We're using it in pub/sub subscriber. And in gRPC server.h. I'm running in fallback mode. All right, Cinnamon. And although we do have this call queue thing here. So for some reason seem to be directly molesting the call queue. And we're still, even in the beginning, we've got this boost ASIO stuff here. So let me ask Gemini, does the Ray project use gRPC? And it will tell me yes, it does. And then I'll ask follow-up questions. Ray leverages gRPC to enable efficient and reliable communication between its various components, such as Raylets, the worker processes that execute tasks and manage resources, the GCS server, and Redis. And does it use gRPC in the usual way, or does it rebuild aspects of gRPC based on the gRPC internals that end users don't usually use? So at least Gemini says it primarily uses gRPC in its standard form, leveraging its core functionalities for efficient communication. It doesn't seem to have, okay, it does employ some specific configurations and optimizations, custom RPCs. So why is it directly manipulating the call queue, etc.? The primary reason Ray directly manipulates the gRPC's call queue is to achieve finer-grained control over task scheduling and resource allocation. So the task scheduling algorithm often requires more flexibility than RPC's default scheduling mechanisms. Okay. While direct manipulation offers benefits, it's important to note that it can introduce complexity and potential risks. If not handled carefully, it could lead to unexpected behavior or performance issues. Ray's developers likely have implemented safeguards and best practices. So let's say if I wanted to re-implement something like Ray using more standard gRPC, what gRPC features could I take advantage of? Let's say advanced gRPC features to tune scheduling, load balancing, etc. There used to be a proposal for gRPC load balancing that I think was in effect while I was still at Google, and that seemed to stall, and load balancing was, I feel like, offloaded to something like Envoy proxy or something similar. So I don't know if I don't have a sense right now of what gRPC has in this regard. We have things like call prioritization, etc., deadline propagation, metadata, gRPC interceptors, channel options, and so on. Okay. I'll ask, does gRPC support both client-side and server-side load balancing? Okay. I don't know if that's true, but let's move on. Okay, so at least according to Gemini seems to think as a high-level thing that Ray's mostly using regular gRPC. There's some stuff in here that looks a little bit strange to me, but it's, first of all, it's been a while since I've used. I don't think I've ever really used C++ gRPC. I've used the C++ internal Google version, Stubby, a lot. So I could just maybe don't recognize all the things. But it does look to me like Ray is peeking under the hood, and Gemini seems to have confirmed that a little bit, that it's manipulating the call queue to get scheduling stuff. I don't really know how to think about that. That seems to add complexity and the maintenance burden of the Ray people. And it's unclear to what extent it's necessary. I don't see anything really, like the first gRPC commit I saw said that we're going to start using gRPC for this thing, and it already had like the call queue kind of out and naked. I didn't see what they were doing with the call queue, but that suggests that, before they really did a lot of tuning, they started like peeking under the hood. So that gives me a little bit of pause, but maybe it's not such a big deal. At any rate, I think we have a good idea so far of what Ray is up to. We could dive further into the implementation details. However, I think that part of the idea is that the implementation details are going to change. It would be nice to see where they actually, call a Python method. So presumably that would be somewhere in core worker. We have libjava. Actually, no, maybe it's in the Python stuff. So let's get rid of this. I think I opened up Python somewhere. Here's CPP. Should we look at CPP? Worker, default worker. So the default worker just runs the task execution loop. We have runtime. Where do we think the task execution loop is? How about we could look at task executor. We have a task execution handler, which you give it some function name, a buffer of arguments, and message pack is yet another protobuf-like thing, which is the actor point, which is an S buffer of an actor pointer. So now we have message pack. I think we have protobufs, and we had that documentation that seemed to be like a byte serialization thing, and we also have pickle. So it kind of seems like we have like all of the message serialization stuff. The protobuf provides a significantly more compact transmission format than message pack. However, while JSON and message pack is JSON like. Yeah. Okay. All right. So, and then we're using a bunch of boost stuff again. We've got boost and we've got abseil, which I think probably trod a lot of the same ground. It seems like to me as a developer, it seems a little bit like they don't have like a good consistency story yet. And maybe they will over time. I don't know. Okay. So we have this invoke thing. Execute task, I think, is probably what I want to look at. We're looking at the header, so this is not yet the implementation. But we have the callers are PC address, the task type, the task name, etc. I don't remember if they call her, CC. Okay, great. And let's see, where's the execute task. So this is logging stuff, checking stuff. We're going to get the function descriptor, which is maybe from the message pack or protobufs, something that was sent to us, I think. And you get the typed descriptor and the function name. And if the caller is empty, then that tells us whether we are doing cross-lang. I'm not sure what cross-lang is. Maybe that means that like C++ is trying to execute Python or something. And we're going to set is retriable error to false as a raw pointer. And we have getting some status ready. And we're going to set data to the null pointer, which is a shared pointer to a message pack S buffer. I don't know what an S buffer is. S might be string, but it seems to be just for pointers. This is the reference, but what is it? S buffer is simple buffer. It uses malloc, free, and realloc internally. So it's just some, I guess, message pack version of a C buffer. And we've got some args list, and we're going to, I guess, loop over the args and do some stuff with them. And if arg get data, then we're going to reinterpret cast the data. Yeah. Yeah, this seems like... So we're just taking data, I guess, that was placed on the network, and we're just going to like execute it, I think, essentially. We have some serializing data, etc. Somewhere down here, we should get to actually executing it. Okay, so if the task type is actor creation task, then we're going to call get execute result on the function name, the argument buffer, and a null pointer. And I forget what standard tie does. It somehow ties together status and data. And the current actor will be set to data. If it's an actor task, we do something else. Let's look at our normal task. So if it's a normal task, we call get execute result on the function name, the args buffer, and the null pointer. And we just get the data back. So get execute result seems to be the thing that we need to look at. Does tie just create a pair? Creates a tuple. Yeah, so it just creates a tuple. All right, let's look at get execute result. Need to add more details of the error message, such as object ID, task ID, etc. So that's a to-do item. So we have this entry function thing. I don't know what that is. We have, I'll ignore the actor for now, just so we can see the simpler case. The entry function is set to function helper, get instance, get executable member functions of func name. And then we might debug log that. They're going to log all the function names? Seems like a privacy issue. But okay. So they're they're going to they're going to do this entry function on the func name, the args buffer, and the actor pointer. So I'm guessing entry function is an actual function object returned by this this function helper get instance, get executable member functions. And then we're just calling it as a function. And this is the thing where finally we call it C++ function. That's what I'm guessing. So let's see if we can find this get executable member functions. It should be in function helper, probably in the CC file. So get executable member functions takes a function name and calls remote funcs.find on the function name, so that remote funcs seems to be doing the work. If we don't have it, then we don't have it and we error out. Otherwise, we just return the thing that we found. So where is remote funcs? We emplace some stuff on it. Wait. Okay. Load all remote functions. So we're going to load all the remote functions, I guess, all at once. Both default and user dynamic library static link library API.so, which has a singleton class, Ray runtime holder, blah, 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 blah. Okay. So we've got this boost DLL import alias, remote function map t, lib internal function string. Hi. Hello, Mohammed Hussein. How goes it? Again, I think I can't keep this above other stuff, but let me try the following. No. What am I doing? I'm taking a look at Ray. The, the source code of Ray. I can never get OBS to behave. Okay, so this, whatever this is, this seems to be loading some DLL, essentially loading a file using Boost to take like a shared object and getting its implementation. And that's the, I guess, get remote func. And I don't know where function maps was, but essentially we're going to okay, so this is get remote func. Then function maps is what we get by calling get remote funcs. So maybe that gives us maps. We're using a lot of auto here, so I don't know the types of anything. The thing I learned with auto was always to only use it if it was obvious what the right hand side returned, which is usually like if the right hand side has a constructor that has the type, for example, string of foo. So it's unclear what all of these types are, but I'm going to guess maybe some sort of map. And we're going to get, so I guess the map's first element is a pair. And the second element is a something. And then what is the entry function? When you call load all remote functions, you pass in entry function, perhaps. I don't know what that means, but this seems to be the logic that does it. So let's take this whole thing and give it to one of the AIs. What does this code do? So it's dynamically imports a function from a shared library at runtime. Okay. So this is just importing a function from a shared library. There's some template argument which I didn't even notice. Okay, so that's what we're doing. That's how we get the C functions, and then we're presumably doing something similar from to get functions from Java and Python. Let's see if we can find out where that happens. Is this JS? This so Mohammed is asking, is this JS? This is not JS. This is a pretty complicated project, but we were just looking at C++, and now we're going to start looking at Python, both in the same project. But this is a project that has Python, Java, C++, and I think that's about it, unless you count the configuration languages and whatnot. Let me grab this chat from a better window here, since OBS is not behaving. Do I maintain notes? No, I don't. I do maintain notes of various things in my life. I don't maintain notes on these, although I do go back and watch them if I need to like relearn about something. It would just be too much like during the live stream to take notes. And also, just as a general rule, I found that the notes I take the first time I encounter something are almost always useless. So I like to take notes. Like if I'm writing down tasks that need to be done or broken up, whatever, I do that. But the first time I encounter something like a topic or whatever, I try not. I used to take lots of notes, but now I don't. So that's the thing. Okay, so here's the Python stuff, and we'll probably end here. So Cloud Pickle, it does seem like they're pickling a bunch of stuff. Cloud Pickle fast. Data experimental includes internal job submission, runtime environment, serve, train, widgets. Is this part of the UI? Why are there widgets? Remote function. Remote function is probably where I want to be. I'll ignore Cloud Pickle. Serve has things like handle, gRPC util, schema.py. So some Pydantic stuff. I think that's like Py typing information. I'm not going to read all that. Okay, so train this is going to be like interfaces to existing AI stuff. I think so. I see Hugging Face, sklearn, I'm going to guess is probably scikit-learn, TensorFlow, tests, Torch, XGBoost. We just looked up Torch, right? So I did a video on Torch, and so let's look at Torch Trainer. Class, Torch Trainer. A trainer for data parallel PyTorch training. At a high level, this trainer does the following. Launches multiple workers as defined by the scaling config. So I guess you have to configure how many workers you want. So you would think that one of the benefits of using something like this is you get, there is some auto scaling behavior, but certainly you can, it seems like you can write down how many of each thing you want. It sets up a distributed PyTorch environment on these workers as defined by the Torch config, ingests the input datasets based on dataset config, and runs the input train loop per worker. And then there's some guides and some example. And this, I think, is not. I think the real information is probably in the configs. Although I don't know. Here we go. Config.py. So the config is the config a Python file, or is the config, or is config.py the thing that imports a text file? Okay. So the Torch config has arguments like the backend to use for training, the init method, and some timeout information, and so on. Shut down Torch, etc., etc. So I honestly don't know why you would use something like this for training as opposed to something like Kubeflow I don't know if Spark does training, something that's more oriented towards batch operations. But you can. And there are some examples. I don't know what Horovat is. I think that's the one thing I don't recognize here. Distributed training framework for Tensor something or other. Probably TensorFlow, right? Keras, PyTorch, etc. Okay. Yeah, I'm learning by reading and understanding the developers' codes. I think that source code is the source of truth about what happens in any repository. So a lot of times, if you're working on a large enough project, for example, at a big tech company, the documentation might be out of date, or you may not have the time to read all the documentation. But you can typically jump into the code pretty quickly, and so that's a thing. That's a thing you can do, and you can learn about how it works. It's just a different perspective on than you get from something like a high level conceptual overview or the documentation, and so on. So here's remote function. I'm going to guess that if this is not where they figure out how import the Python functions, then it's going to point us to where that is. But I think there's really not much. I think there's not much difficult to do. You just have to, compared to in C++, you have to have the compiled code, which we got from the shared object. In Python, you just have to have the text file, the script, right? So let's see if there's just some way, presumably, of loading a text file and getting its function. I don't know if they start a Python interpreter to do that, or if they have a way of hot loading functions into the file. So this is some stuff about GPUs. When GPU is used, set the task non-recyclable by default. Okay, this is just setting stuff up. Function is this, signature is none. Options. Configures and overrides the task invocation parameters. Okay, so it seems like from the Python is larger and more verbose than a lot of the other languages. So maybe the Ray people are Python folks first, and that might explain some of the other things I felt was like maybe a little bit weird about how they were doing things. We have this underscore remote. Submit the remote function for execution. So this is the submission logic. And we've seem to have some sort of task option stack because I keep seeing pops. And here's invocation. There's some more cross-language stuff. This is maybe so that like Python can, maybe so that Python can submit like C++ or Java functions, etc. And getting a bunch of stuff, and then override the task's remote signature in docstring. So this is some called a self underscore remote, and we're setting remote to remote proxy. So this is the main thing this proxy I think is doing is passing in our own default options. Otherwise, args and keyword args gets passed in unmolested. And then if you try to call a remote function, then you get an error. So instead of trying to call, try underscore function name dot remote. Why not just make call remote? Then it would be like a remote procedure call. Okay, so this is, I think this is the client side. I don't know if we're going to find I don't know if I'm easily going to find the server side, and I don't even know if it's worth it. I am curious about what's up with the widgets. Class which provides basic HTML templating. Render an HTML template. Okay, so some web interfaces. This is possibly written in Python, and is possibly part of the core. The core whatchamacallit. We have so I guess dashboard might be part of that. DAG should be directed acyclic graph, and I guess they're building up the DAG in Python. I didn't see DAGs in C++. Abstract node for a node in array task graph. A node has type function node, data, etc. Huh. Okay, so why do you need DAGs? This could be for a couple of things. The most obvious to me is if you have multiple function calls that are composed of remote functions, then you have to build up something like an abstract syntax tree. And that would be a directed graph. And you would need some way of slicing up the graph, figuring out what is parallelizable, sending those to possibly different workers, and coordinating the results. I'm guessing that's essentially what's going on here. Although I'm looking to not look at this much anymore, and I'm not really sure. But let's look up, I guess, Ray DAG. Lazy computation graphs with the Ray DAG. Oh, I'm missing chats here. They provide more specialized fine-tuning approaches, which take information from the runs and then select the next training parameters to pass. Yeah? I don't know about Kubeflow, but there's some specialization related to ML. Yeah, I think Kubeflow does that. So they have, I think that's one of the examples in Kubeflow. Although I will admit that I've looked at so many of these repos that I may be confusing Kubeflow for another one. But Kubeflow pipelines was the one that I looked at. And I think that they had things for like hyperparameter tuning, which sounds maybe a little bit like what you're talking about. The training data is that there are parameters inside of the training, and then there are hyperparameters that tell you about how you should decide one level up, like Yeah, just like one level up. Like maybe the learning rate might be a hyperparameter, and I know that Kubeflow has like support for that. I think that probably in Ray and in Kubeflow, they're mainly relying on existing tooling that has support for those things, and then the goal of Ray is to make interfacing with the existing tooling, which data scientists, data engineers are already familiar with. And the goal of Ray is to be probably like as unobtrusive as possible, while also making it easy to parallelize quickly. That's my guess. Okay, so this is something about lazy computation. RayDAG is designed to be a developer-facing API where recommended use cases are locally iterate and test your application authored by higher-level libraries and build libraries on top of RayDAG something or others. Okay, so this is developer-facing. So you're supposed to build your own DAG. So for example, whatever actor bind 10 is, instantiate another actor with init value of 10, and then A1 inc bind 2. Call inc on the actor created with increment of 2. And 6 and all of this stuff. So these are, I guess, maybe function calls. Maybe they're not executed yet. And then DAG, we're going to call combine bind A1 get bind and A2 get bind. We're going to combine the operations. So this is building up an execution graph, and it seems like it's the user's job to build it up, which would make sense. Why now that this is in Python? If this is user facing, then they have to have Python handles to all of the DAG information anyway. I don't know if they have a DAG in the sense of like an execution plan that's built up by the scheduler without your knowing as an implementation detail. We do have a Java DAG, but I don't know. I think I'm going to leave it there. That's Ray. Watch it again. I guess I don't. It seems pretty clear what it's up to. There are a few things that are I found a little bit confusing about that I would call essentially design decisions. But that would possibly be cleared up by my reading documentation. I do read documentation as a developer. As a streamer, it's not part of the stream. The idea here is that we're going in blind and finding what we can find, like when you're dropped on an island on Survivor or whatever, and you have to find your way around. So if you read some documentation, I think that possibly some of the design choices would seem really obvious. It seems like a cool project. It seems to be getting a lot of traction. I know Amazon just migrated a bunch of stuff to Ray, and I vaguely recall that what they said was that they got speedups from Ray mainly because they were able to write essentially custom logic for handling their data in a way that wasn't possible. I think they were migrating from Spark. And so that makes sense that Ray is more of a about you write some functions and it distributes them out. And so if you need custom functions, and then that seems like a reasonable framework. Whereas Spark, I think, is more about getting performance out of having a certain structure. And I think that my sense from the article is that Amazon was kind of butting up against those the limits of the structure they currently had. So watch Kubeflow and compare them and contrast them. And I'm sure that there are also really good videos, kind of like high level overviews, like should I use Ray or should I use Kubeflow? I think Kubeflow is maybe more kind of like a batch operation training sort of feel. I don't think you would necessarily use it for something like inference, although maybe they have an inference offering as well. But if you're interested in these distributed systems, also check out the Apache Spark video and Kubernetes, and I think I looked at Cilium. I'll throw a bunch of them in the description. So that's all for now. Thanks for watching.